This video is going to show how to create and analyze a topology for critical nets in OrCAD X Presto. Impedance mismatches, bin traces, and a lack of shielding can create problems that may not be apparent in a schematic simulation, but will be quite noticeable when the board is already in production. New in OrCAD X Presto 24.1 is the ability to create and analyze a topology during the PCB layout to identify these issues before production, potentially averting costly respins. Start by opening the provided design in OrCAD X Presto. Topologies are extracted from the Constraint Manager. Select Tools, Constraint Manager from the menu to open the Constraint Manager. Select the physical domain from the worksheet selector. Select the Net All Layers worksheet to view a table of all nets in the design and the physical constraint assigned to them. To extract a topology, select the desired net. In this case, flow expand bus PPDQ and select net PPDQ30. Select Tools, Explore Topology from the menu. Topology Workbench opens the two topologies, one for the net itself and one for the electrical constraint set assigned to the net. Select the tab for PPDQ30 to view the net topology. I/O blocks corresponding to DDR4 DEM1, DDR4 DEM2, and U2 are shown, connected by transmission lines. To perform transient analysis on the topology, one of the I/O blocks must be classified as a transmitter. For this design, we will make DDR4 DIM1 our transmitter. Select the block. The Properties panel is populated with block properties. Select Transmitter from the Type dropdown. The block updates to show TX, indicating that it is the transmitter. To configure transmitter options, select Set Analysis Options from the workflow. The Analysis Options panel opens at the bottom of the window. Select the I/O Models and Stimulus tab and DDR DIM1 under Model Selection. In the Model Selection table, double-click the main signal cell for data rate and enter 0.05. Set the number of bits to 4, the stimulus pattern to 0101, and the stimulus offset to 1. This will configure the pattern generated by the transmitter block when the simulation is run. Close the Analysis Options panel. We are now ready to run the simulation. Select Start Transient Analysis in the Topology Explorer workflow to run the analysis. When the analysis finishes, the 2D Curves tab opens, showing the data pulses at both receiver models. In the Curves list, expand TX DDR4 DIM1 die pad and check Signal to view the transmitted signal. The Curves plot now shows the transmitted and both received signals. The receiver curve for U2 indicates significant overshoot from reflections, which can be corrected by impedance matching on the PCB. The topology can be modified and resimulated to determine the required design constraints to improve performance and signal integrity. These rules can then be assigned within the Constraint Manager. Quickly create and analyze a topology in OrCAD X Presto to enhance performance of critical nets, determine the necessary design rules, and identify potential issues to improve signal integrity in your PCB designs. For more tutorials, visit us at resources.ema-eva.com, and don't forget to like and subscribe to our YouTube channel.